Hey there YouTube, Doc's Motorcycle Service. Welcome back to the garage. In the past I had promised you a video on the electrical system of a motorcycle, and I hinted at it in bits and pieces in previous segments, videos, episodes, whatever you want to call it, of this series of Hot Donna Stripped Down. So if you're just joining us for the first time and you're just now finding this video, it could be that you have searched YouTube for a specific tag of what you're looking for, like electrical systems or charging systems or what have you, and that brought you to this video. So if you're here for a specific thing, stick around. We're going to talk about the electrical system and the charging system on a 1986 FLST Heritage Softail Harley Davidson. If you just stumbled across this video and you watch a little bit of it and you say, hey, this is some pretty good stuff, there's going to be a link popping up right here that's going to take you to the playlist that has all the videos on it for Doc's Motorcycle Service. At the end of it, there'll be a link to the next video once that video is available. Don't forget to check out the previous videos. And real quickly, there's a pop-up here for a Facebook page that I created called Doc's Motorcycle Service. Imagine that. As I said in the previous videos, Facebook is just a more simpler platform to communicate with you and your questions and allow a community of answers. I don't know everything. I don't claim to know everything. But having a community of people that are wanting to find information and have been working on other stuff, you can sometimes have somebody ask a question and get 3 or 4 different answers, 3 or 4 possible ways to work through that problem. So check out the page, like it, give it a shout. Today, what we're going to talk about in electrical systems and charging systems is some of the stuff that we have laid out on the table here. Here's your speedo, your ignition switch, your dash, so to speak. What you have here, if I can do it, is the 2 looms going back to the terminal block. And from the terminal block, you have your wires, your 2 looms going forward. Linda's not here, so bear with me. To the right hand side handlebar, and then the plug-in for the right side handlebar controllers right here where they unplug. And then over here you have the loom for the left side controls and the plug-in that goes up to the handlebars. So you can see from looking at this that it's been patched up several times. This is sort of a mess in here, and instead of trying to go through it and rewire it, we've just purchased a brand new wiring kit from Pro One that's going to replace all of this and the 2 looms that come back and the 2 looms that go up. Now I'm just going to tell you, I'm still digging into this new wiring harness to see if what it's telling me is the truth. It's leading me to believe that we don't have to use a terminal block, a new terminal block on this, that the looms that come out of it go straight over and plug into each of the connectors that go to the left and the right handlebar system. I'm still trying to confirm that. In the factory configured, the OEM configuration for this, every wire that comes from something or goes to something passes through this terminal block. And you can see the terminal block is kind of messy itself. This is a new one that we purchased for it, along with new connectors. And as I said, I'm still trying to work my way through whether or not we need to use this terminal block. I'm going to call the manufacturer and ask them for clarification, and we'll get into that in another video. Here is what led us to the project that we're on. This is your stator. And again, I'm not going to try to tell you something I don't know about, and electrical systems is something that I struggle with. But basically the stator mounts to the engine case. It sits firmly and does not move. It has these copper wires that are wrapped around it with a metal surface here. Now, the stator is covered by, protected by, and works with this magnetic rotor. This magnetic rotor with the splines that you can see right here, this fits onto the crankcase of your motorcycle, and it turns. Every revolution that the engine makes, this thing makes a turn. And somehow, while this is stationary and this is rotating around it, because this is a magnet, while this is stationary and the magnetic rotor is turning, which I can't turn very easily, while this is spinning, it creates what's called direct current. Now, direct current is current that goes one way. Just remember, it's direct. It only goes in one direction. The motorcycle, most motorcycles, operate on a AC, which is an alternating current. Alternating means it can go one way, and it can come back the other way. Your house works on alternating current. And the alternating current, the direct current, the DC, which is created by this, plugs in to the voltage regulator like this, and then inside the voltage regulator, the DC current is turned into AC current, and then it passes out of this wire to the voltage regulator, which regulates the voltage that's going through the bike. Now let's talk about that for a minute. So your stator creates direct current. It then passes that direct current to the voltage regulator. The voltage regulator. The voltage regulator then, and I think I misspoke a while ago, the voltage regulator then turns the DC to AC and passes it on to the next step while reducing the voltage down to about 14 amps. The stator system, I believe, is designed to create 32 volts. 32 volts created, pushed to the voltage regulator where it's turned from DC to AC, and the amps is dropped down to about 14. From there, the volts go out to different parts of the motorcycle. The power wire, the one wire that comes out of the voltage regulator, this is plugged into the stator. This is your wire out. This wire goes directly to your battery. And remember, the battery has one job, and that is to start the motorcycle, to start the car. That's why your batteries are rated in cold cranking amps, because the vehicle, whether it's a motorcycle or a car or a pickup truck or a minivan or a scooter or a boat or a tractor trailer, from the manufacturer, they determine how many cold cranking amps is required to turn that motor over. A diesel motor is bigger than the motor in the motorcycle. It has more cylinders. It's tighter. It takes more cold cranking amps to turn that thing over. The battery supplies the power to turn the motor. Once the motor starts turning, then either a stator or an alternator on a vehicle then supplies the power to start it, to run all the electrical systems on it, put fire to the components that it needs to have in order to start the ignition process. Now the battery's done, but it's had a lot taken out of it. The voltage regulator has two jobs. It powers everything that works on the motorcycle. So if you're talking about Hot Donna, a 1986 motorcycle, there's really only a few things on there it has to power. It has to power the lights. It has to power The ignition module, which helps with the timing and the firing and the power that goes to your spark plugs, and that spark that makes the gas go boom, which makes the piston go down, which makes the motorcycle go that way. Its second job, because it has two, its second job is to replenish the power back into the battery. As I said, starting something really takes a toll on the battery. I cannot imagine how many batteries UPS and FedEx go through. Think about that for a minute. I was once told that on a properly working motorcycle, it takes approximately 30 minutes of highway speed to replenish a battery after it started the motorcycle. Okay, now does that mean that if you hop on your bike and you ride up a half mile to the gas station and fill up and then try to start it, it's going to die? No. But I about guarantee you, if you sat there and started that bike without raising the idle, I got the garage door open and a fire truck's coming. So hang out for a second. So yeah, if you drove your motorcycle to the gas station a quarter mile and shut it off and started it back, it's going to fire up. And it might even do that 2 or 3 times. But if you sat there and turned it off and then started it and turned it off and started it and turned it off and started it 7, 8, 9, 10 or more times, eventually without power going back into the battery to replenish it, the battery's just going to keep working its way down, and then you're going to hit that button and it's going to go rrr, 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 and it might fire. And then the next time you hit it, it's going to be like it's just not going to work. So UPS drivers and FedEx drivers, I cannot imagine how many batteries they go through, because think about that. They start up, they drive to a stop, they shut it down, they go in, 5 minutes later they come back out, they start it up, they drive 60 seconds to the next stop, they shut it down, they go inside, they come back in. The voltage regulator is going to be doing its thing at idle. So you could take if everything is working properly on your battery, you can take in your electrical system, you can take an ohms meter and set it to the proper setting. Put these on the battery terminals with the seat off, of course, or you could plug them into a battery tender cable that goes to your battery. You can test your battery by turning it on and looking at it, and then if you hold those in there and crack the throttle a little bit, the numbers should come up. That will tell you whether or not the voltage regulator and the stator are working. Remember, when you do that, okay, so you get on your bike and it don't start. You put it on the charger and you charge the battery to full, you put it back on the bike. Now if you want to see if it was the battery or your voltage regulator, take these, set it at the right setting, either put it on your battery terminals or stick it up into the plug for your battery tender, start the bike, you're going to have a number here, a reading from the battery, start the bike. This number is probably going to drop during the starting process. Once the bike is idling, crack the throttle a little bit. These numbers should go up. If they don't go up, one of these is not doing their job. Remember, this has to create it. It sends it to this, and then this converts it and send it on down its way. So you can use that ohms meter if you know what you're doing, and we're not going to talk about that here because I'm not going to get you out there in a situation where you're going to blow your bike up. I know how to do it, but there is a way to take that ohms meter, plug it. If the numbers are not rising, that doesn't mean this is not doing its job. It might not be getting anything from this. So if you put your ohms meter onto the positive and negative terminals of the battery and crack the throttle and the numbers don't go up, then either this is bad or this is bad. Okay, you follow me? Now, there is a way to test this on the motorcycle after it's running, but I'm going to let you explore that. So if you tested this separately from testing it through the battery and the numbers didn't go up, again, doesn't necessarily mean this is bad. It might not be getting anything from this. And there is a way to test this on the motorcycle while it's running. Again, I'm going to let you explore that. We might talk about that in an advanced video down the road. But again, think about everything this does. It recharges the battery and it supplies all the power on the motorcycle. Well, you might have a 2013 CVO that's got LED lights, that's got a big sound system, that has a computer, which has GPS, which has a radio, CD player, plug-in mic so you can talk to your spouse, cruise control, turn signals, all these things. This makes the power that this converts and runs that. Now, if you saw the previous video where we were talking about a ground, now we're going to talk about how ground works on your motorcycle. Alright, so I hope you can see this. The numbers are just kind of moving around. That's very typical of these things. And what we have here is we have a battery, and we've got a cord on it for the battery tender, and we have a positive lead to the positive side of the battery and a negative lead to the negative side of the battery. Now, if you've ever paid attention to your bike, you'll notice that the negative battery terminal goes straight to the frame. Alright? The positive battery terminal typically, specifically in this scenario, goes to the starter solenoid for the starter. And we're going to talk about that in a minute. Well, you say, well, okay, so if this goes to the frame and this goes to parts of the body, well, guess what happens if I touch these two cords together? I'm going to get a spark. That's right, because it closed the circuit. Now, that's why they tell you before you do anything to your motorcycle, always disconnect the battery from what you're working on. Can you imagine? All right, well, let's go through this first. So we're going to go ahead and put our terminals from our meter onto the battery. And I'm going to try to hold this with one hand, and it's not going to work, maybe. Let's see if I can wedge it in there. If I can wedge that in there just right and touch this right here. Alright, so you can see that we've got just over 13 volts coming out of the battery. Alright, now, so we established that the battery is good. Okay, well, notice that we have our negative terminal from the negative side of the battery over here, and we have it hooked to a bolt on the headlight. No other cords except for this one. Alright, can you see that? I want you to see that. There's nothing else here. There's nothing up my sleeve. This black terminal from the battery represents the ground that goes to your frame. So this would go to the frame. The frame is attached to the neck, which is part of the neck. The forks go into the neck, and then this is mounted to the, I guess you might call it the nautical that attaches to the forks. All of it's connected together. So imagine all that between here and there. I believe the yellow is the regular beam, and this is the high beam. So nothing's connected to this. So check it out. We have our ground right here to the frame, which represents the battery, and we touch that and the headlight comes on. We go over here and touch this one. That's the high beam, low beam, high beam. So now that's how ground works. Imagine everything between the battery and this headlight. It's all metal. Now, if you don't have a good connection, let's put this back on this beam here. Alright, so we got a good connection there, right? So we're going to take this off and we're going to move it down here to the washer. Well, look at there. The washer doesn't have good contact because it's moving. Is the bolt good? Yeah, it is. See, did you see that little spark? See that little spark in there? But that bolt's dirty. Alright, so right here, see where that's nice and clean? Alright, that mounts to the natical, which mounts to, actually this mounts directly to the lower stem assembly, which is mounted into the neck, which is part of the bike that connects to the battery. That is how all this works. But watch this if I mess with it a little bit. See that? If I don't have a good connection, then things aren't going to work right. So going back to a previous segment of my video where I talked about the frame and the guy telling me I had to clean all of those surfaces where the dash is going to mount, where the fender's going to mount. Because remember, the fender has running lights, turn signals, brake light, brake light. So if you looked inside these things, you would see there's only one wire going to this tip light. That's the power wire that gets there when you turn on your ignition switch and your running light comes on. Or there's a lot of wires going in here because there's a bulb here that does two things, a bulb here that does two things, and a bulb here that does two things. So you've got to have power going to both sides of these bulbs. One is for the running light, the other one is for the turn signal. But you don't have a ground because these bulbs are in this piece of metal, which attaches to this piece of metal, which attaches to the fender, which attaches to the frame, and the frame is grounded by the battery. Again, remember, I don't have two wires going to the bulb and the headlight. I only have one wire, the low beam and the high beam. Let's look at it again. High beam, or regular low beam, and high beam. We take our ground, we put it on here. I turn the motorcycle on, the running lights come on, boom, there's the low beam. I flip the high beam switch, the power is turned off to the yellow wire, and the power is turned on to the high beam. Follow me? I flip the high beam off because a car is coming at me, and the circuit's now closed back here. One wire, because this is grounded to the frame. I got one more simple experiment for you. Battery. We have a lead coming from the negative side, and we have it going to the toolbox. The toolbox represents something metal. There's nothing else around this thing. This is our battery tender, charger, cable. So I'm just going to put this here. Alright, so nothing touching this. So here's our lead from the negative side of the battery. We're going to attach it to the metal side of the toolbox. Alright, and we have another lead coming out going to the ground side of the horn. Keep in mind, most horns have a ground, but you only have to use one. But this one has a rubber buffer here, separating the mounting bracket from the frame from the horn. So your ground is killed right there. So we got our power wire and our power for the horn. So we're going to take this lead because this is now grounded to the battery, and we're going to put it on the ground in for the horn. Now, here's our positive lead. Comes from here. If I touch this right here, it's going to spark. But if I come over here and touch it to this wire, we get the horn sound. So, as you can see, again, that's how your ground works. That's how everything on the switch works. When this represents your horn button, okay? This comes from the battery, goes into the terminal block that you can't see, goes up to the horn switch on the bike. When you press it, it closes the in power and the outgoing power switch, taps them together, completes the circuit, power comes back out, hits the power. Okay, so I hope that makes sense. Just keep in mind, and I feel like I'm forgetting something or leaving something out, but things have to close in the circuits. So if you have any questions, please go to the Facebook page that's popping up here. Let's excuse me, use that platform to ask questions. It's a lot easier. I'm on Facebook more than I'm on YouTube. I get pop-ups from YouTube. It's a process. And I normally try to quickly get back and answer people's questions. I like to respond quickly. So if you got a question, find the YouTube page. Here's a little, I can't put a link on it because YouTube is stupid. They want me to verify it's mine by uploading a file to the Facebook page. But the page that I have is a fan site, and it will not allow this thing to load up to it like a traditional web page will. So look for Doc's Motorcycle Service with that pic in the banner. Like the page, ask a question. I'll get back to you. Where are we at? Okay, well, we've got parts still coming in, and just like I mentioned in a previous segment, we're not ready to use those parts, but we got them ordered, and it's a good thing because one of them was wrong. As soon as it got here, I figured out it was wrong. I got it sitting in a box right there to take to UPS today. Got lots of parts coming in. Called the chromer this morning because of the COVID thing. He's running behind. And we are not able to pick up any of those pieces. Talked to the motor guy. I'm going to go by there today. We've got to make some decisions. One of the decisions that we have to make is whether or not we're going to close up this inner primary. If you've been tagging along, Donna had an open primary. She had an open belt drive system. The belt drive system does not require any type of lubrication. The chain drive system requires the primary to be closed up, which means that it has to have a solid inner primary with a good seal to the engine case, and it needs a good outer primary to seal to the inner primary to keep the fluid in the inner primary that lubricates the chain. So the owner of the bike is trying to figure out if he's going to go back with the belt drive system or if he's going to close it up and put a chain drive on it. He's a chromosexual. It's a true word. So I'm going to go by the day and talk to the parts guy and see what it's going to cost us to close that up. Because if we close it up, then we've got to put sprockets on the engine crankcase and the transmission transmission crankcase that allows a chain. Right now, those sprockets are for a belt. So it's going to be a little bit of expense to close this thing up. He likes the belt drive, but I don't know. I'm going to get him prices, let him make a decision on it. We're going to start processing this video right here as soon as I get out of here. And I think what we're going to work on between now and the time all those decisions are made and those parts are coming in is we're going to start working on the new dash and speedometer and the wiring harness and getting it back on the bike. So as always, thanks for coming by. Rate, comment, share, like the page, share the page, check out the Facebook page, leave a comment there. And as always, we appreciate you coming by and hanging out at the garage. And cut.